Hi students, good morning. Today we will discuss two problems, 43 question number and 44 in page number 354. These are important for competitive. Question number 43, page number 354. If f of a plus b minus x equal f of x, then integration of a to b x into f of x dx equal. There are four options given. It will ask MCE. So let us do this one. Integration of a to b x into f of x dx. Let this is I. And use property a to b. What property we should use here? A to b f of x dx equal to a plus b minus x dx. So x replaced by a plus b minus x. F of a plus b minus x dx. So a to b a plus b minus x into f of a plus b minus x equal to f of x dx. Splitting here a plus b integration of a to b this into this f of x dx minus this into this a to b x into f of x dx. This is I, which is also I. This is I. Transfer this side, 2I equal to a plus b integration of a to b f of x dx. I is equal to a plus b by 2 integration of a to b f of x dx. This is the answer. Check the option. Which option is right? A plus b by 2 integration of a to b f of x dx. D option. D option is right. Next, the question number 44. Integration 0 to 1 tan inverse 2x minus 1 by 1 plus x minus x square dx. See, integration of 0 to 1 tan inverse of this is given like this: x plus x minus 1. X plus x is 2x, right? 1 plus x, take common here, x minus 1. See, which in the form of tan inverse x plus y by 1 plus x into y. So tan inverse of x plus y by 1 plus xy equal to tan inverse of x plus y by 1 x plus y by x minus there. Okay, here minus it should be there. If it is plus, so this I can write like this: x minus 1 plus, I am going to take here x, take common, 1 minus x, minus will get common. See, minus into x and x minus x square minus minus plus x. Correct. Right? Tan inverse of x plus y by 1 minus xy equal formula tan inverse of x plus tan inverse of y. Integration of 0 to 1 tan inverse of x plus tan inverse of y. Y means x minus 1 into dx. So integration of 0 to 1 tan inverse of x dx plus integration of 0 to 1 tan inverse of x minus 1 dx. See, this is we can use by property. We can make it short form. Okay, x replaced by 1 minus x. When you replace x 0 to a, f of x dx equal to 0 to a, f of a minus x dx. X plus, right, 1 minus x minus 1. Okay, you will get 1 get cancelled. Tan inverse of minus x. Tan inverse of 0 to 1 tan inverse of minus x dx plus this is same. So in 0 to 1 tan inverse of x dx, tan inverse of minus x is minus tan inverse x 0 to 1 tan inverse of x dx. So what is the answer is 0. Here by property x is replaced by 1 minus x. 1 minus x minus 1 get cancelled minus x. So tan inverse of minus x. Tan inverse of minus x is minus tan inverse x. Same limits get cancelled. The answer is 0. Next, area of roller curves. Next topic, application of integral. Application of integral, that is called area of roller curves. Application of integrals. The weightage of this topic as per previous. Now latest we don't know. Okay, application of integral. This is, we say, another name is area of curves. Area of curves. Area of under curves. Okay. The weightage of this topic is 2 marks, 5 marks guarantee, and 2 marks plus 3 marks. How many marks here? 10 marks. As per the previous. Okay. Here some topics, some questions also they have removed. I will tell which they have removed. Okay. Which they have not removed. That while discussing I will tell you. So first of all, basic concept, area of curves. Application of integral, what we are discussing, differentiation. After discussing differentiation, what is the next topic is? Application of derivative. Now so far we have discussed integration. So now what is the use of integration? The application we will discuss. That is application of integrals. Okay. There are many. So one of the topic we have given. That is area of curves. See, let y is equal to f of x be curve and continuous function on closed interval a comma b. Continuous means no break. The function is continuous on closed interval a comma b. Okay. So this is x axis, xo x dash, yo y dash. Let this is the y equal to f of x curve. This is closed interval a comma b. A this is and this is b. In between, no break in this graph. Okay. And this x axis. Now you see, now I am going to draw in the vertical strips. This is vertical strips, small vertical strips, very small I am making. What is this? It look like rectangle. It should be rectangle. Are you following? So what is the length? This is y. Y coordinate. Y. What is this? This is x. This is small x is denoted by delta x. So dx. Small x is denoted by dx. Very change in x, very small dx. Are you following? What is the area of small strips? This area. What I shaded, that area. Tell me that area is length into breadth. So y length. Breadth is dx. So this is the area of this. Now I want the whole area. This whole area I want. To get that area, we should apply integration. Integration means sum, whole part. From where to where? A starting lower limit, B upper limit. Then we will get the whole area. So the integration of a to b by dx equal to area bounded by f of x, the curve f of x, and the lines. What is the line? This line name is, it's a vertical line, x equal to a. What is this line is? X equal to b. If the line parallel to x axis, the lines are x equal to 0, x equal to a, x equal to b. Okay? Are you following? The area bounded by the curve f of x and the line x equal to a and x equal to b with x axis is denoted by integration of a to b by dx. This is. Are you following? So this is the one of the application. Because this type of curves area we can't find. We know the rectangle shape if we circle if there we can find. There is a formula. But for this there is no formula. So this type of curves area how to find by using integration. So that is the one of the application. Are you following? Y dx, why should I take y dx? Y is the function. Length. Dx is small. So it is an area of small rectangle strips. Okay. Then the whole area, to get whole area we should apply boundaries, limits from a to b. Then we will get the whole area. Integration of a to b y dx. Y is nothing but f of x. f of x and y and both are c. So this we can write here, integration of a to b f of x dx. Understood? With dx means with x limits. Okay? If it is, for example, the curve is like this, for example, here types of curves, the area of curves like this. The curve may be downside is a y equal f of x. Here x is equal to a and x is equal to b. So this is a small strip. This length is y. This length is dx. So y dx only, this also y dx only, area of small strips. Okay, integration from a to b. But this is their downside, you will get minus. But area always positive. The graph is there. The y, the area bounded by the lines x equal a and x equal b below the x-axis. This is below the x-axis. This is above the x-axis. If it is below the x-axis, the area is minus. Then you multiply by minus, will get positive. This will get negative, and if you multiply by minus, will get positive. That is the area. Are you following? The graph is there in the downside. Okay, we should multiply by minus. Or you can apply mod also, because if come minus, mod become a positive. Yes. Are you following? If you not apply mod, what happen? Minus will get. Area always positive. That's why. Okay. Next, for example, the curve may be always not like that. The curve may be like this. Like this. It's a A, it's a B. This is x is equal to A. And this is x equal to b. This area is a y is equal to f of x. Okay. Here, don't take a small strip here. Y dx area. Tell me a2. This is a. This b. A to b. If you take, you will lose this part. This part also you will be count. But don't take a to b. Because this graph, this area, this small strips area, maximum up to how much will take? Up to this only. So we should identify this point. How to get this point? This is on x-axis. In the graph, in the curve, put y is equal to 0. Y is equal to 0. You will get this point. After getting this point, that I am taking x is equal to c. X is equal to c. Tell me the area of this integration of a to c y dx. This is a1 plus this is a2. Here are small steps. Tell me c to b y dx. Is it correct? No, it is there down. So we should write here minus. Or if you put minus here, we should apply here mod. Okay, if you not apply mod apply, for example here 2, here minus 2 minus 2 also will get 0, but area will be there, 0 will get, okay, 0 means wrong it is. Okay, so to get, why you should get 0 here? Because it's down. If it's down here, you will get negative by using the different concept. So when the negative comes now, we should make it positive. Area always make it positive. Okay, you can apply minus or you can apply mod. Whatever. This is okay. And for example, next type of curves may be like this. There are two curves may be there. One is y equal to g of x. Another curve is y is equal to f of x. It's bounded by lines x is equal to a and x is equal to b. I want not this area I want. The area between two curves. To find that area, first now I am going to find f of x area. First I am going to find f of x. Tell me f of x area. This is small strips y dx. Integration bounded by a to b. If you find this area, how much you get? This much you get. Whole area will get. This also will get. Next, g of x will be there here. If you take g of x, integration of a to b, here f of x dx. This is f of x dx. Next, g of x dx. If you find g of x dx, what area will you get? This area will get. This much will get. Okay. So how to get this area? Minus. So this is the f of x occupied big area, g of x small area. So this area, to get this area, f of x area minus g of x. So minus, you will get the area between two curves. The shaded part equal to integration of a to b f of x dx minus integration of g of x dx. Here f of x is greater than g of x. F of x greater than g of x. How we can identify area? So f of x occupied area this much. G of x from here to this. So which is small? G of x. So f of x is greater than g of x. Then integration of f of x minus g of x dx. So integration of a to b f of x minus g of x dx. Okay. Sometimes the curves, different curves, how will it be there? If it is like this, the way of finding. If it is like this, the way of finding I am explaining. That is area between two curves. If area between two curves, if they ask, first you identify big function and small function. Then the meaning is the big function nothing but it occupied big area. Small function means it should be occupied small area by with respect of x-axis. As per the area, we should identify. Next, for example, the curve may be like this. Here x o x dash, y o y dash. Always have taken x axis. Y axis may be filled. Okay. If the curve is like this, it is bounded by y axis. Like this. How we can find? Okay. If it is like this, the equation in the form of x is equal to f of y. If it is like this, the graph is y is equal to the graph. If it is like this, y is equal to f of x. If it is like this, bounded by y axis, then the equation in the form of x is equal to f of y. Okay. So draw small one. Whatever this y, here a and this is b. Tell me this equation of lines. Y is equal to a, y is equal to b. It's a parallel to x axis. What is the equation of x axis is? Y equal to 0. I am going to take small strips, alternative strips here. What is this length is? dy. This length is x. So what is the area of rectangle is? Small strip is x into dy. Now apply integration. It is bounded by limits a to b. What limits it is? Y limits. Here dy means y should be there. There dx means x limits. Okay, so integration of a to b x dy means the graph is occupied by this is the area bounded by the curve x equal to f of y and the lines y is equal to a and y is equal to b with positive y axis. Positive y axis. A to b x dy. So equal to area, the required area, this whole area. If this is same procedure, what we have discussed in x-axis with respect of x-axis, if it is there this side, you should multiply by minus. Same, if it is above x-axis, positive. If it is below x-axis, the graph is there below x-axis, negative. The same thing, if it is there positive y-axis, right side of y-axis will take positive. The graph is there left side of y-axis, negative. Same, one more function is there here. For example, here y is equal to a, this is, and this is y is equal to b. Here one function x is equal to f of y. This is x is equal to g of y. This area we should find. So which is occupied big area? G of y. So integration a to b, g of y minus g of y means the whole will get minus this you subtract this is f of y into dy. Will get the area of between two curves. This is the way. Are you following? So the area of curves, one of the application of integral, definite integration. Okay. Are you following? Got the point? First, let's find what is the meaning of this area of small strips. When you apply this, whole area will get. The area bounded by function and lines y is equal to a and y is equal to b. And if x is there, x equal to a and x equal to b. And with x axis, if your x is there, dy is there means with y axis. Are you following? See, sin x graph, if you take 0 here, pi by 2, pi. Here 1, sin 0, 0, sin pi by 2, 1, sin pi is 0. So this area we should find. To find this area, what is the name of this function? Y is equal to sin x. What are the limits here? It is bounded by x is equal to 0 and it is x is equal to pi. Pi. Now I am going to small strips. What is this length is y. This is dx. So y dx, the area of small strip. Integration. Now I am going to find the boundary. This area, I want the whole area. This what I shaded, the whole area. It is bounded by 0 to pi. X limits only. So integration of 0 to pi. Y means sin x. Sin x dx. Sin x integration minus cos x. Limits 0 to pi. So minus cos pi minus 1 minus cos 0 is 1 minus 1. So 1 plus 1 which is equal to 2. So this area, the sin x bounded by the with x axis, one shape upside, how much it is? 2 units. If it is half part is there, 1 unit. This is 1 unit, this is 1 unit. If you take 0 to, this much only if you take 0 to pi by 2 sin x dx, you will get 1. This is 1, this is 1. Same, if you continue like this up to 2 pi, this is how much area? 2 units only. But while solving you will get minus 2, then multiply by minus. Okay, so in the shape of sin x, okay, one shape either upside x axis or downside x axis. How much it occupied? 2 units. So that is very important for the competitor. It's same thing applicable for cos also. 2 units only. For example, integration of 0 to 3 pi by 2 sin x dx. If they ask, very easy, listen here. 0 here, pi by 2, pi, 3 pi by 2. Draw the graph. How much is unit? 2 units. This is 1 unit. So what is the answer? 3 units. 2 plus 1 is 3. Understood? It's same thing for cos x also. Integration minus pi by 2 pi cos x dx. If they ask, here minus pi by 2, 0 plus pi by 2 plus pi. Tell me cos minus pi by 2 is 0, cos 0 is 1, cos pi by 2 0. Next cos pi minus 1. Tell me this area 2, 2. This area 1. 2 plus 1 we want you can check it. This is 3. See, cos x integration sin x. Limits. Apply upper limit minus lower limit. But you should make it separate, not like this. At a time you can't find it. You can't find at a time, right? Because the graph is there downside. So you should find the way of finding integration minus pi by 2 plus pi by 2. One part. Next pi by 2 to pi. You will get the answer. See, minus pi by 2, pi by 2 cos x dx, pi by 2 pi cos x dx. Cos x integration sin x. Limits minus pi by 2 pi. Sin x. Limits pi by 2 to pi. Sin pi by 2 is 1. Sin minus pi by 2 is minus pi by 2, so plus 1. Sin pi is 0. Sin pi by 2 is 1. It is there downside, so minus is. So plus 1. So 1 plus 1 plus 1 answer is 3. The graph is there downside, so we should add here minus. Or we should apply for that. What a point? See, when you, if you not multiply minus, what answer will get? 1 plus 1, 2 minus 1 is 1 will get. 1 will get. Wrong one. That's why if the graph is a downside, we should multiply minus. So area of sin x graph, cos x graph we can find by using integration. From this bit 5 marks question guaranteed. Here one example. Example 1, which is important, 5 marks question. Find the area. Find the area. Find the area enclosed by circle x square plus y square equal to a square. Find the area enclosed by the circle x square plus y square equal to a square. See, you know the area of circle. What is the area of circle? Pi r square. What is the radius? A. Tell me the answer. Pi a square. The area of circle. Okay. Now let that one by using integration we can find area of circle, which is important 5 marks question. See, first draw the graph. For getting draw diagram only, you will get 1 mark. Most important diagram. Okay. X square plus y square equal to a square. What is the center of the circle? 0. X square plus y square equal to a square. Center of circle 0 comma 0. First year you have learned this. Sir, equation of circle conic section. Okay, what is the radius? A. So this is radius A minus A plus A minus A. This is circle. This whole area we should find, right? To find this, center is 0 comma 0. This all 4 parts area same or not? Yes. Now I am going to find first of all this area. This area I am going to find this area. After finding this, I am going to multiply by 4. Will get whole area. Okay. So this small strip, tell me this length is y and this is dx. So it is bounded by, tell me, is this part bounded by O A B. Tell me O A B is x is equal to 0. What about this? X is equal to A. Are you following? It is there up only. This much only. O A B curve. So integration of y dx 0 to a will get this area and multiply by 4 will get the whole area. Right? Now y we want x square plus y square equal to a square. Tell me the y square equal to a square minus x square. So y is equal to root of a square minus x square. Positive plus or minus, minus show down, plus represent up. Are you following? Tell me now. Area of, see, area of circle equal to 4 into area bounded by area enclosed by area bounded by, tell me, curve OAB. So 4 into integration, the OAB boundaries, tell me, limits. What is the limits? X is equal to 0 and x is equal to a, 0 to a. Small strip area y dx. So 4 into integration of 0 to a, y, root of a square minus x square dx. This we have discussed in the previous exercise. What is the formula? A square minus x square integration. See, this is as per the new syllabus they have removed. 4 into integration of 0 to a. Tell me, formula integration of root of a square minus x square formula, x by 2 root of a square minus x square plus a square by 2 sine inverse of x by a. Limits x is equal to 0 and x is equal to a. Apply upper limit a by 2 root of a square minus a square plus a square by 2 sine inverse of a by a. This is the upper limit minus lower limit x is equal to 0 into 0 0 plus a square by 2 sine inverse 0 by a is 0. So 4 into a, this is 0 plus a square by 2 sine inverse of a by a is 1. That is 0. A square by 2 into 0 is 0. Now 4 into a square by 2 sine inverse of 1 is pi by 2. Get cancel pi a square. Check the area of circle. Area of circle is pi r square. Pi a square. We got it. Okay. This is, we can find, we have taken here with respect of x-axis. Okay. So you can take with respect of y-axis also. We'll get same. See. Here I am taking like this, small steps. Whatever this is x and this is y, dy. Then integration of x is dy. Limits, if you want it, these limits you should take it. What is this limit? Y equal to 0 and this is y is equal to a. 0 to a. So integration of 0 to a, x means x square plus y square equal to a square. X is equal to root of a square minus y square into dy. Then multiply by 4 and simplify. We get the same. That you try yourself. So you can do with respect of x-axis or with respect of y-axis. Both answer will get same. Okay, this is very important 5 marks question. This diagram is 1 mark. Okay, writing this part up to this 1 mark and writing this, getting this 1 mark, getting last answer is 1 mark. Total 5 marks.